Welcome to Easy Higher Mathematics.
Inference theory of predicate. So for these types we need 4 formulas. That is, first one is universal specification. The notation is US. That is, for all x, P of x is equal to P of y. Its meaning is the given statement is true for all values of x. It's a contrapositive only, UG, that is universal generalization. That is, P of x is equal to for all y, P of y. Now next one, existential specification, that is ES. That is, there exists P of x equal to P of y. So that is, for some particular values the given statement is true. That is, this is true for only some particular values. That is, the notation is there exists Ex. It's a contrapositive of this only, that is P of x is equal to there exists y, P of y. So these types of problems we need some formulas. The formulas are this: P and Q that is equal to P, P and Q is equal to Q, etc., etc. So these formulas you have to by heart. This is maximum we use all at most all problems in this mathematical logic. So you have to by heart these formulas. So let us go through an example. So this is the one example. There exists x, P of x and Q of x implies there exists x, P of x and there exists x, Q of x. So its meaning is we can take this there exists to inside the bracket. That is for P of x as well as Q of x. So first one, step 1. The step 1 is you write this one, that is there exists x, P of x and Q of x. We introduce this statement inside this proof. Therefore, the reason is rule P. Whenever we introduce this statement, the reason is rule P. Second one, this is for particular values. That is, there exists some value. So we can use, instead of x, we use some particular value A. That is P of A and Q of A by rule ES. That is this one. This is our formula, that is ES, existential. Now we use the next formula. What is the formula? P and Q equal to P, P and Q is equal to Q. We can split into two terms. So that is the third one, P of A, then fourth one, P of, not P of, Q of A. So P intersection P and Q, then P comma Q. So these are formulas. So we use rule T. Formulas we use rule T. These are from the second statement. So we use the number that is equal to 2. Now fifth one is P of A. So P of A, what we need? There exists P of x we need. So once again we rewrite it to P of x. First we write into individual values or particular values. Now splitted into two terms. That is P of x separate, Q of x separate. Once again we have it to make there exists P of x. So if it is P of A, it is for particular values. Instead of P of A, we can use there exists P of x. So that is there exists P of x. This is for P of A. then 6, there exists x q of x. First one is from 3 and second one is from 4. So the rule, this is also we use the formula rule EG. Rule EG. These also rule EG. What is rule EG? EG is the counter of positive. That is existential counter of positive. That is existential generalization. So that is rule EG. So the last one, that is 7. Here there exists P of x, there exists Q of x. So we can write there exists x, P of x, and there exists x, Q of x by rule T. By rule T from 5 and 6. From 5, 6. Because this is P, this is Q. P, Q implies P and Q. That is our definition. P, Q, or this one we can apply. This one. This is same only. P, Q, these are same. P, Q implies P and Q. By this formula, we can write there exists x P of x and there exists x Q of x by the statement. From this statement is from the statement 5 and 6. So we put the number 5 and 6. So this statements from 3. So we can use this is 3. And this statement is from 4. So we use this is 4. So finally we got the answer, that is there exists. That is finally we got the answer, that is there exists P of x and there exists Q of x. So this is proof of this problem. So the next one is little big problem, that is there exists x, f of x and s of x implies for all y, m of y implies w of y, comma there exists y, m of y and negation w of y implies for all x, f of x implies negation s of x. So here notations are very important, that is there exists x, here for all y, here there exists y, here on negation, as well as here for all x and implies. So first, here this term contains implies. This term contains implies, but this term contains no implies. So let us take this term, that is there exists y, m of y and negation w of y. We introduced this statement, that's why we put rule P. So this is there exists y, this is only for particular values, therefore we use instead of y we put a, that is m of a and negation w of a. This is rule of existence. This term is derived from the first statement, that is why we put equation number 1. Now negation of this one. Negation of this one. It is better to you take one negation common from this one. You take one negation common from this term. That means there is no negation. When you take negation common, you can put one negation. Here we take already one negation, so that negation also we can take as common. So that is from these two terms, you take one negation common, that is negation m of a, and it becomes r. This is by De Morgan's law. And if you take negation and it becomes r, If there is any negation, that will negation there. So negation means negation will be cancelled. So this is negation of m of a. This and becomes or. Here already on negation, so don't need to put a negation. This is by the formula, that is why we put rule T. Now negation P or Q is equal, that is a formula. P implies Q. P implies Q, that is negation P or Q. We can take this for this one or this for this one. So here this term is here, so we can take this one. That is, instead of this P or Q, negation P or Q, we can use P implies Q. So that is negation, this is for P implies Q. That is also formula rule T. And this term is we got from statement 3 or the third steps. That is, we put 3. Now, next we take the remaining terms. So what is the first term? This term contains no implies. This term contains no implies. We derived to implies term. The same term we derived to implies term. So that means this term contains implies. Remaining two terms, these two terms are remaining, that also contains the implies. Then we can easily connect it to formula. So now we take the next term, these two terms. We take these two terms. So that is, there exists x, f of x and s of x implies for all y, m of y implies w of y. So this is also for a particular case. This is also for a particular case. We put instead of x, we can put a. So that is f of a and s of a implies. This is generalized term. Anytime we can put a or b or c. So that is also we can put a, that is m of a implies w of a. So here for all y means we can put the same value here. So that is f of a and s of a implies m of a implies w of a. So that is by the formula rule ES, existential specification only. Now this is also derived from 5, so we can put 5. Now negation f of a and s of a. This is the formula rule T. What is the formula? Negation q comma negation q comma p implies q, that implies negation p. Its actual meaning is negation q and p implies q, then it is negation p. So this is negation q, then p implies q implies negation p. That means already we have negation m of a implies w of a. Now its negation only this one, m of a implies w of a. Its negation only this one. So if it is p, then this is negation p. Or if you take including this negation p, you take p, its negation is equal to negation of negation equal to m of a implies w of a. Two things. One, if you take this is equal to p, then this is negation of negation, that is equal to what? Cancel m of a implies w of a. So what we get? Negation q comma p implies q, that implies negation p. So answer is negation of this one, that is negation of f of a and s of a. Once again here some confusion maybe. So once again, this is f of a intersection and s of a. These two are same. If you take this is equal to p, then this is equal to negation p. So it is better you take this is equal to p. This is equal to q. Then this is equal to negation q. So I can write for convenience. So this is you take q. Then this is equal to negation q. This is equal to negation q. This is so now it is okay. Negation q implies p. So that is equal to formula negation P. So this is equal to P. So that is negation of f of A and S of A. So that is, this term is from there exist. This term is we got from there exist only. Therefore we can write once again negation of there exist x, f of x and s of x. Now negation of there exist means for all. So that is a one thing. So negation of there exist implies for all. So this negation of there exist becomes for all, then f of x and s of x. Now negation of f of x and s of x by De Morgan's law. What is De Morgan's law? P and Q, the whole dash is equal to, sorry, not dash, negation. Negation of P and Q implies negation P union or negation Q. This is the formula. So that is negation of P and Q equal to negation P or negation Q. That means f of x, negation of f of x and s of x, that is negation of f of x or, that is negation of f of x or negation of s of x. So that is equal to, this for all becomes, sorry, this there exist becomes for all, this and becomes or. So negation of f of x or negation of s of x. But what is our conclusion? Our conclusion, the terms contains fully implies. So we once again convert this union term to, once again we convert this union term to implies. So for that the formula what? This is the formula P implies Q, that is P implies Q, then negation P union negation Q. That means the first term contains negation, then that is P implies Q, we can put negation. If here negation P, here negation of negation P. So it's a negation only we will get here. So that means negation, that is negation of f of x implies negation s of x. So this can be one more, we can write as negation f of x implies negation of s of x. If here P, we can get negation P. So negation of f of x. But double negation means negation will be cancelled. So that is f of x implies negation s of x. So this is our required. So next problem, show that the premises one student in the class knows how to write programs in Java, and everyone who knows how to write programs in Java can get a high-paying job. Imply the conclusion, someone in this class can get a high-paying job. So let us do this problem. So for that, first you convert into symbolic form. So that is, that we take that is equal to c of x. C of x, x is in this class. X is in the class, then j of x. So j of x is x knows Java. X knows Java programming. So x knows Java programming. Next one, high salary, that is h of x. So h of x, that is x can get high salary. high salary. So this we assumed. So how to write the given statement? So that is, what is the given premise? That is, one student in the class knows how to write programs in Java. One student knows. One student knows how to write programs in Java. So student in the class, that is C of X. Student in the class, that is C of X. He knows Java programming. That means C of X and G of X. He is in the class as well as knows Java programming. So the premises are, so this is X is in the class. So one student in the class, how to write the Java program. So he is in the class as well as he knows the Java programming. That means the premises are, there exists X class. C is in the class and knows Java. So everyone means all the knows how to write a program in Java, get a high paying salary or yes paying job. That means it is universal. Therefore we use for all. So that is for all X, or we can simply write this also. This is also for all. So for all J of X implies H of X. So this is the first one is both only. Write programs is in the class as well as Java. But here everyone who knows how to write a program. So if you know the program, then only you will get the high salary. So that means it is in the if condition. So if condition means we use implies. Yes. So the conclusion is, what is the conclusion? Someone, that is not universal. So that means there exists. Someone means there exists a particular sum. In this class can get high paying job. So someone in the class means C of X. In the class means C of X, and high salary paying means H of X. So it is C of X and H of X. Now let us prove. Now first you introduce the statement, that is, there exists X, C of X and J of X. So we introduce this statement means rule P. So there exists means it is for a particular. So therefore we can put some value, particular value, that is we taken as A. That is C of A and J of A by rule E. Yes. Now and means we can take separate, that is C of A and J of A. C of A and J of A, that is by rule T. Rule T. Which formula? That is P and Q. Then P and Q implies P. P and Q implies Q. P and Q implies P, and P and Q implies Q. So that is by that formula. This is P, this is Q. P and Q implies P. P and Q implies Q. By rule T. So this is from first statement. and this is from second statement, and this is also from second statement. Now the fifth one, now we take the next one, that is for all x, j of x implies h of x. So this is by rule P. So I cut and write little bit. So that is 5 for all x, j of x implies h of x. So that is by rule P. We introduce the next one. So now 6. So this is for all means we can take particular value. We can take particular value by rule US. So this is from fifth statement. Now the seventh one is, you take here j of a, here also j of a, these two are equal, that is, this is j of a, this is j of a. So we can use the formula P comma P implies Q, that is equal to Q only. So formula is P comma P implies Q, that formula is equal to Q. So J of A comma J of A implies H of A, that is equal to H of A. This is by the rule T. By the rule T, its condition is this only. So that is equal to H of A. Now, so this is from which one? From 6 comma 7. Now, so the third statement that is equal to C of A, when the seventh statement that is equal to H of A, therefore we have the formula. What is the formula? P and Q implies P, P and Q implies Q. That means P comma Q implies P and Q. So the same idea from the equation number 3, that is C of A. Now equation number 7, that is H of A. We can write P comma Q. The C of A is P, H of A is equal to Q. Then P and Q we can write. P and Q. Why? So how will we know to take the C of A or H of A? Because what is our conclusion? Our conclusion saying someone in the class can get a high salary. So someone in the class, that is C of A, and high salary, that is equal to H of A. So we must link C of A and H of A. So we have to link C of A and H of A. That is why here we get C of A. Now we got this H of A. That is P. This is Q. So P comma Q implies P and Q. So this is for some only, because these statements fully we taken from there exist. So we can write this once again to reverse form, that is there exists x, C of x and H of x by E G, by the theory EG. So this is 9th. So this is from the statement 8. So this is our required answer.